Welcome back to Industrial Problem Solving. My name is Dave Roysum. Here we continue our tour of even more ways that you can get stuck in problem solving. We begin with one of the most common. Understandably, everyone wants to know why something happens. In the last modules, we gave you examples of why one machine and not another, why you and not your competitor, and why one wound roll and not another. Here we continue the idea to critique one of the most common of the problem-solving techniques, known as root cause analysis, or RCA for short. Now, don't get me wrong. I am not saying that knowing the root cause is not helpful. It is just that this is seldom possible in the messy real world. Or, even if it is possibly possible, we seldom have the time and resources to figure it out thoroughly. Yes, we do have some models for some behaviors. Yet, in web handling science, this is typically a series of nonlinear differential equations. If I gave you that set of equations for winding and said you need to solve them in a custom-written accretion model, you would not say, "Dave, if you only gave me these equations earlier, it would have made my winding defects so much more understandable." There's often more than a bit of arrogance in RCA and indeed science itself. Very often we don't know why, at least not in any definitive sense like being able to predict trouble. At best, we can predict the risk of trouble. So try to figure out why by reading what others have written. My free and easy search engine, the Roysum Library, can help you with that. But if you can't figure out why, get on with it. If B follows A most of the time, then focus on A. Another serious problem with the root cause method is that one gets the erroneous idea that you have to undo the root cause. Yes, undoing the root cause mechanics, a more accurate statement than root cause singular, is usually the most powerful and often desirable. Yet, you can do good without undoing the root cause. Sure, if you are overweight, losing weight is great because it will help reduce your blood pressure. However, there are many prescription drugs that should also be considered, and these drugs may be even more effective for blood pressure than weight reduction. In my award-winning and trademarked Web401 class, all of my 5,000 students were taught that spreading can be effective for wrinkle reduction even if spreading itself is very seldom the root cause. Often, the answers we get are not pleasant. Smoking and drinking are believed to be poor health choices. That leads some people to point to George Burns, who smoked and drank all of his 99 years. On the other hand, sometimes pleasant choices are overlooked because they did not kill the problem. We talked about the home run thinking pitfall in a previous module. Learning a new problem-solving technique takes a lot of time and effort. Trying to get approval to buy an instrument or sensor will always give your boss sticker shock because none are cheap. Thus, people may use the tool that's in front of them, and that may be okay. Recall that the best problem solvers tend to be lazy. However, maybe that tool in front of you isn't best. Or maybe it's not even useful at all. There's a saying that if all you have in your toolbox is a hammer, then everything will start to look like a nail. That is what this course helped you avoid. It gave you many, many tool choices and then some. There is a minimum sample size needed to make a statistically confident conclusion. If that size is hundreds of measurements, it is a pain, but doable. However, if that size is hundreds of trial runs, the boss will not give you that. However, settling for less is a waste of time, and even worse, you can get the wrong answers. While we are on the topic of sample sizes, it is helpful to know that sometimes you need to do 2 trials. The first mini trial may help you get an idea of variation that can then help define sample sizes for the second and even more determining run. All of my 5,000 Web 101 students were taught how to see wrinkling as a deviation from perfect flatness, as opposed to a rejectable defect. Those did not take that to heart will miss opportunities because you can almost always see wrinkling risk long before QA or the customer complains. Let me close with a situation you want to stay well clear of. It is probably best known by the saying, death by 100 cuts, though there are many other analogies and stories along similar lines. The best way to foresee this terrible trouble is the Pareto diagram that we talked about earlier in this course. It is a plot of cost versus category. Usually the Pareto has an exponential decay curve as shown here in green with a tail on the end for other. In this figure, I show a linear decay. What this means is that you can beat on number 1, perhaps even kill it despite all the odds, and the fractional overall improvement is tiny. Then you move on to number 2, and with a heroic effort, you nearly kill it also. Still, little overall improvement. Then you move on to number 3. Well, you get the idea. This situation is usually a sign of a stillborn product or process, or a machine that is both poorly designed and poorly maintained, or perhaps even a dysfunctional organization. In any of these cases, you may wish to consider a transfer to another plant, or possibly dust off your resume. Thank you so very much for joining me in this problem-solving process. I hope I've made the case in this third of 4 modules on pitfalls that there are many ways to get stuck. I hope I've made the case that looking ahead and avoiding trouble when possible is preferable. However, I've been saving the best for last. Next time, we will talk about the most serious pitfall to problem solving, which is, you guessed it, people.